Hello everyone, welcome back. My name is Shivam Agarwal and this is the project series of machine learning and deep learning projects in Python. In the last video we saw that our first project is going to be credit risk prediction. We have already seen the dataset that we are going to use, that is credit risk analysis for extending bank loans. In this video we'll be seeing how to create this project and how to use our machine learning model for predicting the risk analysis. Okay, using the credit risk analysis dataset. So this is Kaggle Community Platform. I already told you to create an account so that we can also start a notebook right here. When you will open this dataset or any dataset on Kaggle, you will right here see a new notebook option. This option is right available for you to create another notebook and to use this dataset without any external dependency. Okay, so I'll just click on this new notebook and it will create a new notebook with all the dependencies for me. I will be creating this project using GPU because I'll be using some random forest or SVM classifiers that I'll explain to you, and for that it already provides me the GPU for free. I don't need to have any hardware on my PC. So even if you have an older PC or you have a hardcore machine, you don't need to use the hardware on your device. Kaggle Community Platform provides you with all the RAM, CPU, GPU and everything that you need. Okay, so I'll be using this GPU T4X2. This is provided by NVIDIA. It's a very nice GPU. It provides us all the required inputs. So the session is starting, right? When the session is fully started, we'll see the RAM, hardware drive and every resource up here. We'll start with loading the dependencies. So while the session is being started, let us load some values here. Okay, so the session is started. Let me show you how this is going to work. So this is session time. Currently 0 minutes have passed. This is disk amount. We have used 4 GB till now. The maximum allowed is 73 GB, which is quite large. This is CPU and we have 100% of CPU core available for all the cores, right? This is RAM. Maximum of 13 GB is allowed. However, we can extend it to 30 GB. Next, we have GPU over here. Okay, so maximum of 14.8 or 15 GB of GPU is also provided free of cost. Let us try to load the dependencies now. So let me show you the data set also. So while you have clicked on the new notebook option, it has already loaded the data set. This is credit risk analysis for extending bank loans. And this is the CSV file that we are going to use. Okay, we have GPU for ourselves. We are coding in Python and you don't need to access anything else. In the first cell, let's import some libraries. We have NumPy and Pandas for free automatically. Next, I require plotting, so I'll use matplotlib and I'll import it as with plyplot and I'll import it as plt. Next, I require cbond also because I will use cbond over matplotlib for the plotting. Next, we'll require some machine learning models. Okay, so let me just import them also. I'll explain it to you why each library is imported as we use them. Okay, so let me just import in. So the first library that we are going to use is from sklearn. This sklearn is a module that supplies you with all the algorithms related to machine learning. Okay, sklearn provides you with all the algorithms related to machine learning. So from ensemble module, I will import Random Forest Classifier. Okay, so from sklearn ensemble, I will import a Random Forest. So this is a classifier algorithm that you might have already learned in school or college. This is Random Forest Classifier. The next one I'm going to use is from the same sklearn, but this time SVM module. I am gonna import the SVC. Okay, I'm gonna import the SVC. This SVM is support vector machine. You might have heard it also in college if you are working with data science or machine learning. Next, another algorithm that I'm gonna use in this is sklearn dot linear model. Another is linear model, so I'm gonna say linear underscore model. This is another module. Okay, from this I will be importing logistic regression. This is logistic regression. So this is the final algorithm that I'm gonna use: random forest, SVC, and logistic regression. Okay, so I've imported these three. Next, I am gonna use some scaling also. I'll explain you what is the scaling and why do we use this when we use it. Okay, so I'll say from sklearn.metrics I'm importing confusion matrix, and I'm gonna use classification report. Okay, that is it. Next, I am gonna use what I'm gonna use. I'm gonna use a scaler, right? So from sklearn.preprocessing, this is preprocessing here. So sklearn.preprocessing, I'm gonna import standard scaler. While I don't need to use any label encoder today, so I'm not importing label encoder. Label encoder is going to be used in the coming videos. I'll show you how. Next, I'm going to use some train test splitting. So finally, I'll say sklearn.model selection. This is a module which will provide us what we call as train test split first of all, and we'll get grid search CV. We will use this grid search CV with our SVC. Okay, this is a and we'll gonna use the cross-val score also, right? Finally, with matplotlib inline, why are we using matplotlib inline? Because we are going to plot the plots right after the cells. If we don't use matplotlib inline, it might be possible that the plots that we are going to plot are not shown to us, okay, on Kaggle platform. So these are the libraries. I'm sure you might be confused by most of them right now, but I'll show you once we use them one by one, okay, why I have used them. Now let us try to run it first. So you can run the cell on Kaggle using this run, or you can use Control plus Enter while being on the cell. Okay, pressing Control plus Enter, it will execute the cell. So it says invalid syntax. Okay, I forgot an as after this. So you must keep in mind that you have to use the right syntax everywhere. I've used it twice. No problem. When you are working on Kaggle, you don't need to worry about the processes because now it is done. It has already loaded the dataset also. Now we'll try to read the dataset. So pandas library provide us with a method called as read CSV to read this kind of datasets. What we'll write? I will create a variable for data frame. I will call it df, and I'll say pd, that is pandas dot read underscore CSV. This is a function provided by pandas to read this type of files, and I'll say this path. So bankloans.csv. What is this path about? Here you can see a copy file path option. If you copy the path from right here, you are going to paste the path here. Okay, so you can see we have included the path to our CSV file. Right. After this, what we'll say, we'll try to look at the dataset, what it is about. So data frame, when it is imported from pandas, provide us with a method called as head, which will give us the first 5 values, first 5 rows of the dataset. So the first file reads the dataset and second gives us the first 5 rows. Executing this cell, we'll see the dataset. So here is age, employee ID, and all the columns. We see here that all the columns are non-categorical variables, right? There is no any column that has string values. All the columns have the number values. So we don't require to clean the dataset or encode the dataset, right? So this is a pretty simple data. So I have used this dataset. That is why we'll try to look at if this data contains any null values. Suppose there is an employee ID that is null, or there is an address that is already null. Okay. So let us try to understand if it is null anyways. So df provides us with another method called as isNull, and when we use it with some function, it will provide us all the null values for all the columns. Okay, it will sum up all the values and will show how many null values are present in each column. Let's try to execute it. Here we see that except for the default column, we have no null values in any other column. But default column has a total of 450 null values. So we don't require any null values in our default column. So we'll see how many total values are present. So we'll say df dot value underscore counts. This function will describe the dataset with all the values. So if we execute it, we'll see that there are total 700 values that are non-empty, right? So if we delete all the null values of default column, we'll be left with around 700 columns, right? So let us try to do that. We'll drop all the null values of default column. So what we'll say, df equals df dot drop na values. This drop na function will look for all the unavailable values throughout the dataset, and it will drop. Okay, and we are storing it back in the same data frame. If we try to execute it, it is already executed. Okay, so now if we try to run this function again, we'll see that all the null values of default column are gone. Okay, that is how I have cleaned this dataset. I will suggest that you can use some basic aggregate methods for using this drop na function. In place of this function, you can create some aggregate or mean, but because I was having just two values in this data, 1 or 0, I decided to drop the values that are not present. Okay, I have dropped all the rows. This drop na function will drop the whole row where if any one of the value even is unavailable. This is how drop na will work. Okay, let us try to proceed. While we have done this data cleaning process, we will try to plot some data points, like how is age related to debt to income ratio, or how is age related to the income. So is there any relation between two columns? We'll try to analyze using plots. I might say that age might be related to income, and increasing age will result in an increasing income in some way, or an increasing age might result in increasing debt to income ratio. Okay, let's try to visualize them using matplotlib or cbound. So using cbound, I will write two variables. First will be the figure plot and next will be the axis. I will say plt, that is from matplotlib dot subplots. This will plot the figure for us. The size would be, okay, I'll give the size as 20, 10. This 20 will be your rows and 10 will be your columns. Okay, so that is the figure size. Next, I want to plot a figure. How will do? Using cbound, we'll say sns dot line plot. So this line plot will be like a line chart. There will be a line starting from origin or the first place and will be going throughout the data. Okay, so this will be the line plot. On x-axis, what we are gonna plot? On x-axis, I'm gonna plot the age value. This is age. Remember to write it in the same way, age. Next, on the y-axis, I want to write, for example, the income. I'll want to visualize age versus income. So I'll say income. From what data we are using is df. We are using data frame, and the axis that we are using is ax. Okay, so the ax that you see on the right hand side is this value, right? So let's try to execute it and plot the plot. It might take some time for you. Yeah, so as I thought, increasing age results in increasing income up to a certain level, that is around 40. You can see over here, around 40. The increasing age result in increasing income. After that, it becomes fluctuating graph. Okay, this is how age and income are related. So both will be the required parameters. Next, I want to visualize the plot between age and debt to income ratio. Let's do that also. Or let's visualize the plot of income to debt to income ratio. Okay, so similarly, using this only, I'm just copying this, say the same thing, and I'll say this time age versus debt to income ratio, right? Debt INC. It is debt INC, I think. Yeah, it is debt INC. And now if we try to plot this, okay, so you see almost a same debt to income ratio for multiple age groups. So everyone is trying to take the debt according to their income. That is a pretty common belief that generally people have. Okay, so let us try to analyze what kind of values does our parameters possess. In this data, you can see we are going to predict that how many whether a person will be a defaulter or not. So you might have already guessed that this default column will be our parameter. Okay, and all the others will be the usabilities. These all columns will utilize to predict what will be the value of the column default. Okay, so if we visualize what are the values of default, we can say df of default. What are the values of this default column, because this is our most important data point. So we'll say value counts, that you already know what we use for describing a column, and we see that 0 values are 517 in number while 1 values are 183. In this dataset you might find that these two number of values are very different. However, for keeping it simple, I've used this dataset. You can also use another dataset where these values match a little bit. There should not be a large difference between only the two values that are present in the column. Okay, ignoring that fact, let us try to create our training and test dataset. While we work with machine learning and deep learning, what we do is we divide the data provided to us into two halves. The first will be the training dataset and the second will be the testing dataset. Training is always larger than test. They are in the ratio of 70-30 or 80-20 mostly. So we'll try to do it. Now let me go back and show you how we'll do the train test splitting. Remember that I imported this model. From sklearn.model selection, I imported train test split. We'll be using this train test split to split our dataset into two different parts. Okay, let me just create the x and y columns first. So our x columns will be every column other than default column, right? So our x will be every column other than default. So I'll say x dot how to drop all the columns using the drop function, right? So this drop function will be used to drop the column, first column, that is default. I'll say default. Remember the syntax, df dot drop starting with a parenthesis. Next, inside the list you give the list of all the columns that you want to drop. I want to drop just the one column default, so I'll use it in this way. Next, I want to specify the axis of dropping. So the axis will be 1. 1 axis denote the column while 0 axis denote the rows. Okay, so this is how this will work. So x data will be everything except the default column. And what will be the Y data? You might have already guessed. It will be just the default column. So I'll say df of default, right? So this will create our X and Y values. Yeah, so we have created two variables X and Y. Now we want to split this data into training and test. I want X train values. Next, I want X test values. I'm going to write it comma separated. Next, I want to write Y train and then will be Y test. Why am I writing it using commas? Because the function train test split returns us the four values in this specific format. The first value returned will be the training of X. The second value will be test X. The next will be Y train and then will be Y test. Okay. So this is the common convention that you must use. Now we will use the train test split function. Train test split. I have imported it from sklearn.model selection. It will be given the values of X and Y that we had already computed before. We have to specify the test size. Okay, so I have already told you that training and testing dataset will be of different sizes, 70-30 or 80-20. I'll say that the test size will be 20%. So I'll say 0.2. 0.2 will specify the test size to be 20%. Next is the final parameter, that is random state. What will be this random state? Let me explain it to you a little bit. So when you split a data set, it might be possible that the first 100 values are provided in the first training and the next 20 values are provided in the test. Okay, so this might result in non-normalized distribution. This random state value will make sure that the values provided in train and test are based on normal distribution, random distribution, like that. Okay, so you can play with this value of 42. I have tried a lot of times and found out that random state of around 40 to 50 works best for all the models. Okay, so you can play with this value, try to experiment it a little bit, but I'll use 42 for here. This is X train X test and we'll try to execute it so that we get all the four values. Yeah, so this cell is complete. Next, what we want to do? In the data set, you can see that there are values that are ranging from 0 to 100 maybe, some address values that are numeric in nature, some income values that are high numerics, while debt to income ratio are lower decimals. Okay, so everything is kind of very different from each other. What we want to do is we want to scale all the values so that when we try to implement our machine learning model on those different kind of values, it does not get confused and bias one parameter over another. All the features should be trained with the same accuracy. Okay, so we will use a standard scaler for that. Above here, I have defined this sklearn.preprocessing. I have used a standard scaler. This standard scaler will be used to scale all the values. Okay, so to initialize it, you can create a variable. You will say standard scaler. This will initialize it. Next, you want to scale the X values. X train equals your variable name, and next will be a function provided by this module, that is fit underscore transform. This fit underscore transform function will scale all the values of X train and put it back into the same function. Similarly for X test, I use a fit transform function for X test as well. This is how we'll do it. Try to execute it. Okay, so the S of scalar is capital, standard scalar. Okay, this is how we'll execute. Remember, do not try to execute this cell multiple times, because once you have scaled all the values, you don't want to scale them anymore. Okay, that is how we'll do it. Now we are ready with our data of training and test. What we want to do is create the machine learning model. So I'll say creating model. Okay, we'll first try to create the random forest model. So the random forest classifier is a kind of machine learning algorithm that creates trees in more than one form. What are trees? Decision tree might be created in a way that machine learning model is trained to fit every feature that it is supplied with into a way that it predicts the value in the right way. If you want to go into the deep of how random forest or SVM works, then you can let me know in the comments. I'll create a series of all the mathematical implementations of all these algorithms in machine learning and deep learning to know how these algorithms work. But in the projects, we are going to use them without going into mathematical details, right? First of all will be our random forest. Okay, so we'll start it with random forest. Let's create a variable for this. For example, RFC is my variable. We'll say random forest classifier. This is the way to initialize this random forest. And you have to specify how many decision trees you have to create in the random forest. Okay, so in the decision tree algorithm, you create only one tree, but in the random forest, you create multiple trees. So I am going to use n estimators to specify how many trees I'm going to use, and let us say 200. Okay, so 200 times the decision tree algorithm will execute to create a random forest algorithm. So this is how you will do it. Next, what I will do is fit those things. Let me just execute this cell first. It is saying that random forest classifier is not defined. Okay, so maybe I haven't declared it above. So this is random forest classifier from sklearn. Random forest classifier. Okay, there's a spelling mistake over here. I think you might be screaming at me for that already. Let us try to execute it, and it is done. Right. Random forest classifier is initialized. Next, what we want to do is we want to fit those things. Okay, so we'll say rfc dot fit our data. So fit is the function for that, right? So what we want to fit is x train values and y train values. This is the data that we want to fit in this model so that this model predicts our output. Okay, so it is fit now. Next, what we want to do is we want to predict the score. What is the testing value? How well our model is performing. Everything that you have learned about random forest was functioning with this one method. So it is doing everything, and random forest job is done. Now what we have to do is we have to check the score. What will it say? rfc.score. And how will the score be tested? Using the test values. Right. So it's saying 0.8, that is 80% of the score we are getting with the random forest. This is how we are using the random forest. Let us try to implement it in a better way, because here we are just estimating using 200 estimators. We are not using the best parameters possible. Nextly, we are trying to use the cross validation score so that we get an optimum values. This 80% might be possible that it is a result of overfitting or underfitting. We want to say that we have to be sure whether our model is performing well or not. So for that, I will create another variable, for example rsv2. I haven't declared cross validation score before. Okay, I have it. So this cross val score is the one thing that we have imported from model selection. We are going to use it so as to ensure that our model works well as it is by random forest. We are saying cross val score. This cross val score function will take the estimator as our previous model. That was RFC in our case. Then it will take some X values, that will be X train, and it will take some Y values, that will be Y train. Okay. Lastly, it will ask us to specify how many times are we gonna use this cross val score. So this will be specified using CV parameter, and I'm gonna say just 10 times. 10 times you have to execute this RFC fit, take the mean of all those things and put it in the new model. Okay, so if in one process the random forest is biasing towards a parameter, in the next it will be biasing towards something other, but when we take the mean of all those parameters or all those values, we get an optimal score. That is the actual accuracy score. Okay, so that is how we'll do it. We'll take the mean here and we'll specify how better our model is performing in this way. So I am supplying a y parameter over here. It is represented by small y, I think. That is why it's giving me an error. Yeah. So I am using a GPU over here. So it will still take some time. But if you are not using a GPU over here, it will take a lot of time. So I recommend that you verify your phone numbers on Kaggle and use a GPU for all these kind of things. So our accuracy has been reduced from 80% to 79.2%, but we are sure that our model will be able to provide this 79.2 in all the cases because we used 10 times those values. Okay, so let us try to visualize using support vector machine. Our random forest gave us an accuracy of almost 80%. That is not bad, but let us see if we can get a better accuracy using support vector machine. So we'll say SVM is the next model. Let us see how to use SVM. It is in a similar way how we used the random forest. We have to initialize the model, we have to fit the model, and then we get the score. So to initialize, I'll say SV and the algorithm name is SVC. We don't need to specify anything over here. Next, what we say fit with the values X train and Y train. And finally, what we get is the score. Let us try to execute it first. It is already fit. Next, we try to get the score using X test and Y test. So it is giving me 79.2. That was the accuracy with the best of random forest. Okay, that was the best of random forest that we are getting with support vector machine also. But we haven't used any parameters with support vector machine. Support vector machine supports a lot of hyperparameters that we can use for this model. How we'll use it? We'll use it using the grid search CV. In the above section, if you see, I have used this grid search CV from model selection, which I'll be using to get the best parameters possible for support vector machine. Let us see how to do this. So I'll say that I have to create a model and I'll be using grid search CV for this. The first parameter will be what I have used over here in SVM, that is SV. Next will be a list, or I can say a set of values. This set of values will be 3 values. The first value that SVM uses is a C value, that is denoted by this C. It will be having some values. Let's supply a list of those values. The values of this C can range from a decimal value just above 0 to 10 or 20, like that. Okay, so this is generally a smaller value. So I'll say I'm gonna use 0.1 as C, I'm gonna use 0.2 as C, and let's say 0.4, 0.8, 1.2, and you can experiment all those values like that. I'm saying 1.8 also, I'm saying 4, I'm saying 7, like that. Okay, so I'm specifying these number of values. I have to verify which one of these values give me the best model for SVM with C. Okay. Next is the value called as gamma. SVM uses something called as gamma value. You can supply the list of gamma values that you require them in the list. So I'm saying 0.1. Again, this will the same type of values. I'm saying 0.8 also, or maybe categorizing from 1, and I'm saying 2 and 3, just 2 more values. So this will be the decimal values. I am gonna say 4.0 and 7.0. So this was the gamma values. The last value is the kernel. How will the SVM perform? Whether it will be linear or it will be RBF. Okay, so we can say RBF value it might have, or it might have a linear value. Okay, so these are the parameters that we can specify inside this SVC initializer, but we want to check which of these values together will give us the best model. Okay, so that is why I'm using this. After this set is provided, I'm also saying that the scoring of this model will be based on accuracy. We are majorly focused on accuracy of the model than anything else. Okay, and the total number of parameters, the number of times that we are going to execute is 10, like the random forest. Let us try to run this program. Okay, so it is done quite quickly because I'm using a GPU over here. Next, I'll try to fit this using model.fit again, and we have the values xtrain and xtest. Oh, ytrain actually. It will take some time now because I am running these values with each of the value. So like there are thousands of possible parameters, and I am executing each parameter 10 times. So it will take some time. I'll recommend that you use GPU over here. However, it is done quite quickly because I'm using GPU. If you do this on your local machine, it will take minutes or maybe hours to execute this kind of program. That is why I'm doing everything on Kaggle. So we have our parameters over here, and we'll say we want the best parameters of your. Okay, so model has been already created, but I want the best parameter out of those. So I'll say best underscore params. This is the value that we want. If I say C is 0.1, gamma is 0.1, and kernel is linear, I'll be getting the best value of SVM. Okay, so let us try to use these values. So I'll say model 2 of SVM with C as 0.1, with gamma as 0.1, and with kernel as linear. Right, so this is how we'll do it. Next, we'll try to fit it. And we'll get the score using xtest and ytest. There's a spelling mistake. So if I try to execute it, now I'm getting an 82% accuracy. Remember, the last time we executed SVM, we got 79%. But with the optimal parameters, we are getting 82%. It is above 80%, and it is better than the best of random forest also. So till now, when we have used random forest and SVM, we have got the best accuracy in SVM. Lastly, we'll use logistic regression also quickly. In the same way that we have used the other methods also, we'll say logistic regression. We'll say that fit, or I'll just copy all of this to fasten up the process because this video is getting a bit long, but as you have created the project, you might be a little happy as well. right? So let me execute it a little bit, and we are getting 83%, right? So in the best parameter possible with SVM, we've got 82%, and similar accuracy we are getting with logistic regression as well, right? It is 83%. You might run it multiple times to check whether it is perfect or not. I'm going to show you the last thing, how to use a heat map also. Okay, above in the import module, you can see that I have imported this confusion matrix over here. Okay, so I might use this confusion matrix to create a heap map so that you know what are the difficulties that this program is facing. Why are we getting 83% and not 100%? Okay, so I'm saying that y predicted. So this yp will be a variable that will store the predicted values of the default column. That will be using, okay, logistic regression I'm using, and I'm predicting the values for x test. You can use this predict function to predict a value for your own values also regarding this x test. Okay, next I'll create a variable for confusion matrix. That will have the parameters of y test and y predicted. So this y test will be the values that are default in our default column. This y predicted are the values predicted by our model for that column. Okay, these are the two, and they should match as much as possible for our model to perform best. Okay, we'll plot it. You already know how to plot it. Figure and ax values. That will be equal to plt.subplots, and we'll say the figure size would be 20,10. That is it, right? And finally we plot the heat map for this confusion matrix. This confusion matrix is a matrix of numbers, 4 numbers. In heat map you can visualize it possibly better. Okay, so this heat map takes a confusion matrix as an input. If I try to draw the heat map, you can see this is the 0 value for predicted. This is the 0 value for test values. The lighter the column, the better it is. Okay, so these two columns, the first column and the final fourth column, should be as light as possible. These two columns, the second column and the third column, should be as dark as possible. You can see that the first column is very light. It is saying that our accuracy is almost to 80-85%. This column, that is one predicted and one testing, is pretty much dark. So you can say that sometimes it's possible that our model is predicting that the person is not a defaulter, but it is a defaulter. Okay, so that is how you have visualized the heat map. You can use this heat map in other plots also to plot whether your predicted values are matching your model test values or not. Okay, that is how you create your project. This is the complete notebook where we have included the libraries, dataset. We have worked on cleaning the dataset. We have created random forest, SVM, and logistic regression model. And we found out that SVM and logistic regression work very well on our data. Right. I'm going to save this as credit risk, and I'll provide the link to this file in the description box. You can look up to it. I'll suggest that you create this project on your own first while viewing this video, and if you are stuck at any point, you can always go and check up. Okay, all the links to the code, the documentation, and the Kaggle platform are mentioned in the description. You can check below. That is it for this project. Thank you. See you in the other video with another project.